All right, we're going to take a look at a technique for taking derivatives of things that we don't have rules for really. We're going to look at taking the derivative of y equals x to the x power. So it kind of looks like a power rule, but it's a little bit different than what we've done before because both the base and the exponent are variables, so they can change. It's different than x squared. So the base is moving, but the exponent is fixed, or like a 2 to the x. So the base is fixed, but the exponent is moving here. So it's a little bit different. And we're going to use our good friends, the logarithms, to help us out here. Remember, the logarithm's a nice function. Yeah, and we can take the logarithm of both sides. So this becomes ln of y equals ln of x to the x power. And then we're going to use the power rule for logarithms, not for differentiation. Power rule for logarithms, which is going to bring that x in front of the logarithm. So it's going to just send it right down. Okay. So that's x times ln x, and we know how to take the derivative of that. That's just a product of functions. The derivative of ln of y is 1 over y prime by the chain rule, and then we have the product rule. Derivative of x is 1 times ln of x, which is the second function, plus the first function of x times the derivative of the second. Derivative of the second is 1 over x. Multiply both sides by y, and y is the same thing as x to the x, and then inside would be ln of x plus 1. And there you have it. So that was too bad, was it? We take a look at one other one. So y equals x plus 1 to the 1 over x. Again, both the base and the exponent are moving, so it's not a rule that we have had before. So we're going to go ahead and use our good friend the natural log. So we're going to natural log both sides. And this time I'm going to be a little bit more efficient and use that power rule to bring that power of 1 over x down in front. And then again, I have a product of two functions, 1 over x times ln of x plus 1, so that will require the product rule. Derivative of ln y is 1 over y prime by the chain rule. And then derivative of 1 over x is negative 1 over x squared times the second function of ln of x plus 1 plus the first function of 1 over x times the derivative of ln of x plus 1, which will be 1 over x plus 1 times the derivative of x plus 1, which is just 1, so it doesn't change anything. Multiply both sides by y is x plus 1 to the 1 over x, and then I'll clean this up a little bit. You can do more which if you want, maybe find a common denominator, but this is about as far as I'm going to go. That's all the calculus stuff. We're done with that. The rest of it's just algebra. Okay? So if something weird like where the base and the exponent is moving, we will assume that, well, because it's x to the x power, the x is probably going to be assumed to be a positive. Otherwise, we get all kinds of craziness going on where we might have imaginary numbers and we're going to keep it real. So we'll assume that both sides are positive so that when we feed it to the natural log doesn't like any negatives or zeros. It's a happy creature. So we're under all those assumptions, taking the natural log is going to be well defined. Okay?